So in the last notebook, we wrote rules to manually define what concepts we wanted to extract from the text. And this was great because it let us extract these clinical concepts that Spacey didn't recognize, but it was kind of a pain to go through and extract all of them. And if we're going to be working with a much larger corpus, like we're going to in the last notebook this week, that's going to be a little too much effort. So here we're going to try another approach. So other than rule-based, the other type of NLP is statistical or machine learning. So here, just like we did in the machine learning week, we take data which has been labeled and we train a machine learning model to perform whatever task we're interested in. And here that's going to be extracting clinical concepts from text. So the model that we're going to use was trained on something called I2B2 data. I2B2 is an organization that hosts NLP competitions. And so we're going to use a model which was trained on one of these tasks. So we downloaded this model in the introductory notebook, and we're going to load it by using Spacey to load it in here. And this looks pretty similar to a normal Spacey pipeline. So we've got a part of speech tagger, a dependency parser, and a named entity recognizer. But if we look at the NER component, this looks different from what we had in Spacey. So this is trained on the problem, treatment, and tests that we've been working with in the previous notebook. So now let's look at one of these clinical texts. This is an example of one of the sentences we saw in the last notebook, and let's see what our model does. So it extracts as entities ABX and his infection. So this is pretty close to what we did in the last notebook with the rules. So ABX is a treatment, and before I had said that infection is a problem, this model also includes the phrase his infection, which is a little different than what I would maybe do, but is more or less what we want. So now let's take all of those texts that we worked with in the last notebook, process them, and look at them. So now let's go through this, and you can see that for the most part it's doing pretty well. So here this is one really long phrase. I would probably just call this congestive heart failure, but it still got it. So here it got this treatment, but it did miss this one. So this is a problem with statistical NLP, or with any NLP, is that sometimes you're going to miss things, and there's not much we can do with machine learning now to fix this. So here also another mistake, it said CKD stage, but it didn't get 4. But here it did get 3. Here it got cough, fever, infections. Coumadin is a treatment, her atrial fibrillation, and her AF. So pretty good, but we saw a couple of errors. So think about what would you do to fix those errors. With machine learning, there's not much you can control over the model. But can you think of another way that you would modify the output? Okay, so look at this now, and let's look at this sentence. So there's no evidence of pneumonia. So it correctly extracts pneumonia as a problem. But is there anything else that we need to extract from this? Anything that would be useful for us to know? So, although it correctly identified pneumonia, something that's really important to understand is that there is no pneumonia there. So there's no evidence of, meaning that it's negated, and the patient doesn't actually have this condition. So our model doesn't understand that, so we're going to do a little bit of extra work so that we can recognize when concepts are actually experienced by the patient or when they're not. So we will do that in the next notebook. I'll see you there.